I would like to introduce two new experts that are going to participate in the discussion here. But before I do that, I want to say thank you to the Purdue University Institute for a Sustainable Future. They have set up this webinar and enabled us to have it and made it possible. So thank you to them. The two new panelists who are joining us, the first is Ms. Dora Taggart. She is President and Chief Executive Officer of Microbial Insights Incorporated. Ms. Taggart is a global ambassador for molecular biological tools, presenting as an invited speaker at conferences and leading hundreds of technical workshops worldwide and co-authoring guidance documents. Dora has received several awards, including the Women-Owned Business of the Year Award, Business Person of the Year Award, and National Groundwater Association Technology Award. Dora earned her degree in biomedical engineering from Vanderbilt University. And I'd also like to welcome Dr. Clayton Wukich. Dr. Wukich is an associate professor and interim director of the Maxine Goodman Levin School of Urban Affairs at Cleveland State University in Ohio. Professor Wukich's research focuses on disaster response and risk communication, specifically dealing with new knowledge on how governments use social media during crises. So thank you both for joining us today, and I would encourage all the panelists to turn on their videos, and I will start the conversation by first asking Professor Loeffler a question. Professor Loeffler, you had mentioned there's a concept called aerobic degradation and anaerobic degradation that you examined. Can you share for the listeners what that means in terms of groundwater or sediment in the East Palestine area?
Okay, I try. So what we noted is that this environment where this accident occurred and then downstream, it's very heterogeneous. So you can imagine if you have a sediment and you have flowing water on top, that a few centimeters or less than an inch into the sediment, oxygen becomes limiting. So in the top part, you will have oxygen available. So you can envision there organisms that can use or utilize vinyl chloride as a substrate and couple this to oxygen reduction. They can grow in the top part of the sediment. But the oxygen will be quickly consumed. And if you go lower in the sediment, there will be no oxygen. So their vinyl chloride cannot be degraded with oxygen as electron acceptor. There we look for anaerobic processes, reductive dechlorination, where anaerobic bacteria can utilize vinyl chloride as electron acceptor. And so in many subsurface environments, let's say groundwater aquifers, we actually see these organisms to coexist. And the rationale to explain this is that it's not a strictly anoxic environment or an oxic environment. Even if an environment is called anoxic, you will always have pockets where oxygen is available. So most of these aquifer systems are heterogeneous in terms of oxygen availability to microbes. And therefore, it does make sense to explore both processes, aerobic and anaerobic degradation of the contaminant. Another thing I would like to mention, when we sampled in June, parts of Sulphur Run were actually dry. There was stagnant water puddles, right? But there was no continuous flow because it didn't rain in an extended period of time, no rain. So then we were there, and when we were there overnight, there was a heavy rain event. And then this entire creek was carrying water. So there was a substantial difference between a dry spell and then after a rain event. And you can imagine that this has a lot of consequences for the geochemical conditions the microbes experience in the sediment. So therefore, it does make a lot of sense to explore contaminant fate under different geochemical conditions. And this is what we did.
Thank you. That's very helpful and a great description, which kind of dovetails into a question that I wanted to ask Ms. Coelho. Your study put together the exposure pathways or the potential chemical exposure pathways for VOCs in the creeks. Can you tell us a few things that influence chemicals leaving the creeks? Because I think Professor Loeffler mentioned that water levels increase and decrease in the creeks. Would that have an impact on VOC levels in the air?
Professor Whelton, I'm sorry, but the connection, I think it cut it. I didn't hear the question.
Would the water levels in the creeks, if the water is contaminated with VOCs, would that influence the VOC levels in the air near the creeks?
Yes, absolutely. Actually, the different levels of chemicals in the air near the contaminated creek, it can vary because of different factors, like the wind speed and direction, chemical volatility and temperature, and also the terrain of the area. So like as Professor Loeffler was saying, he found during the certain time of the year that the creek was it didn't have any water. It also influenced the volatilization of the chemicals present in the creek, and also how the volatilization of each chemical can easily evaporate from the water to the air. So if it's more volatile or less volatile, it also makes a big impact in the air contamination. And the characteristics of the terrain as well, such as if you have a lot of trees covering that section of the creek, it's gonna trap those chemicals in that area instead of dispersing them more quickly in the air. So other weather conditions such as humidity, pressure, rain will also influence whether the chemicals will disperse or settle in near the creek.
Thanks. Thank you. Professor Jung, you all created a new method to identify chemicals in surface water. Can you kind of explain to the listeners how easy or difficult and time intensive that can be in contrast with methods we already use? But if we send a water sample to a laboratory, what do they analyze it for VOCs, and how does that compare to what you all did?
Thank you, Professor Whelton. Very, very good question. So currently, there are many techniques, and most used method for chemical screening of water samples is gas chromatography, mass spectrometry, also short known as GCMS. And GC flame ionization detection is also used. That stands for GCFID. So they have been used to analyze VOCs in drinking water, in wastewater, in groundwater, in surface water. We also have US EPA methods, and I think many of the listeners may be familiar with the TO15 that is used for air samples, and method 8260D for the water and soil samples. And both of these methods also use a GCMS to examine the volatile organic compound loadings in the samples. So, these are excellent methods, very helpful, but they do come with a tedium of having to bring your sample to the lab. You have to spend time in preparing the sample, and that results in longer delays in sample processing and analysis, which can slow down the chemical disaster emergency response. So what we wanted to do was to use a sophisticated instrument that is as powerful to provide speciated chemical data. That means you're able to see what is the chemical class you are looking at in terms of compound readily, rapidly in a van setup where you do not need to pre-treat the sample. You can really collect it, set it up, sample it, look at the mass spectra, and make a decision. So essentially, we would like to make these rapid decisions in a serious situations where decision making really has a very important role to play, especially during the first day, second day, just starting from very hours to the whole sequence of events that is triggered during a chemical disaster. In terms of answering your question regarding what was the most difficult part, quality assurance and quality control. So it is very, very important because when you have a sensitive situation on your hand, you want to make sure that your samples are not contaminated in any way at all. So for example, the method that we have come up with and proposed, we have even purged the headspace volume of the vial, which means we filled it with zero air, which is clean air. So even when you're capping the sample, if there was a contamination from the atmosphere, it is not going to bias the sample. We're incredibly careful in the quality assurance and quality control. And this way we can isolate the actual sample that we have collected, be it water, soil, or any other, and really understand what is in it. And if we can understand that, my hope is really that we can be better informed, we can make better decisions, and really protect the communities at risk.
Thank you. But that kind of dovetails into a question for Dr. Spearing that we received. Dr. Spearing, sampling was a big issue. The topic of sampling was a big issue that seemed to be flushed out through your survey. How can we advocate for everyone to have equal access to resources after industrial disasters?
Yeah, that's a great question. So one of the key pieces is clear mechanisms to access support, right? And so it goes back to clear communication and risk communication about, what are the options, who is eligible, and how do they access it, right? So even things about where would you go, right? Who do you request to? So that's one big piece of it, is really communicating how it can be done. And then also I think it goes back to who's in the room when decisions are made. And so with increased community engagement, there's more opportunities for equitable access to resources. And so this goes for sampling and testing, as well as, reimbursements for hotels when folks were evacuated, right? So it goes with more than just sampling and testing. So I think those are the main pieces around that, as well as not only having access to the sampling and testing in the first place, but access to clear communication of results. And so that could even go back to standardized forms and standardized reports that go back to community members, no matter who conducted the sampling, right? Because a lot of times post-disaster, there's multiple agencies, multiple folks and consultants doing the sampling and testing. And there's variance in how it's communicated back. And so I think one kind of simple solution is to have a standard format of what is reported back to community members, which is, easier said than done. And I think it's something going forward that can be standardized and we can work towards.
Thank you. Yes, standardization, I think, is a cross-cutting theme here across many of the studies, which kind of leads us to Ms. Taggart. Ms. Taggart, you and your company and staff have been involved in numerous chemical incident scientific support activities across the globe. Can you share with us, some examples of how you and your team have assisted others? Maybe one example.
Yeah, sure, Andy. I'm happy to talk about this. Over the last 33 years, our company has been looking at global projects, and our focus is to understand these biological communities. So we've done work on all 7 continents. We've analyzed lunar material for NASA. We're on a panel right now with experts looking at ways to clean up perchlorate on Mars for future colonization. And the thing is, all of these projects are interesting and unique, but together they really expand our knowledge about the power that microbes have on the surface and in the subsurface. So whether we're studying ways to control acid mine drainage, I just came back last week from South Africa looking at that, or if it's a chemical release like we're talking about here, there's commonality in applying what we've learned. And there's 2 important projects I can think of that come to mind. Most people have heard of the Deepwater Horizon spill. And after that incident, we worked with researchers at Lawrence Berkeley National Lab who used our sampling device called a biotrap, where robots place them at different depths in the ocean so we can start to understand rates of degradation, how these compounds are broken down, and also which bacteria in particular are actually eating these compounds. Next, we worked with the regulatory agencies on that same project to understand the changes in the biological composition, how this might affect toxicity of other organisms in the area. And then finally, with the engineering firms who are out there trying to employ different technologies to help clean up the spill, because bacteria are typically an important part of any remedial process. So we can help them understand if the techniques are increasing or inhibiting activity. And then one other quick example I wanted to give you is off the coast of China. We had a stakeholder that hired us to try to understand compounds that were settling down to the ocean floor. So again, we put biotraps down and divers dove down into the ocean, placed them into the ocean floor, and we looked at microbial activity, rates of degradation. So for me, thinking about it, microbes are just a powerhouse, right? We saw this at East Palestine and some of the work that Frank presented that we found. And I'm definitely biased on my love for microbes, but I think these mighty organisms that outnumber us on our planet and in other galaxies are really important to the sustainability of our planet, to others, and understanding them is a critical part to any type of natural disaster that occurs.
No, thank you. Yes, these lessons here from this disaster are more it's needed to translate the discoveries here into broader policy and scientific adoption approaches. In with science, we generally have the interaction of social media and risk communication. And so I wanted to fall back to that a little bit with Dr. Wukich. Dr. Wukich, what variations did you see in terms of risk communication messages with the East Palestine disaster, and what are the implications for people taking protective actions?
For the question, Andy, but first I've got to ask, it's not fair for you to throw a question at me after we've heard from a subject matter expert who's planning to do operational work on Mars. So that's a tough act to follow.
It's a tough follow. Yes.
Yeah, for sure. So what I would say is that in terms of protective action guidance, the official guidance that community members were receiving, that the initial messaging was quite straightforward and effective in terms of just the initial 1 mile evacuation guidance. But as the event cascaded, the guidance really started to vary, especially from the open burn on. And Professor Loeffler mentioned the lack of specific protocols for first responders. And I would add that also applied to public information officers as well. And this observation is really bolstered by the work that Lauryn Spearing did and Joe Tolan did with their semi-structured interviews. Because we see that messages really varied based on actor and their interests. So, and one thing that I think that we need to note here is that the response system, especially in the beginning, really depended on the polluter, the responsible party, Norfolk Southern, as an active responder and a subject matter expert. And this, is obviously kind of a clear conflict of interest that creates problems. It's quite problematic, not the least being the effect on public trust in the response operations. So the complex dynamics of the incident and the inconsistent messaging from kind of one inflection point to another led to a lot of unanswered questions, as did the lack of kind of continuity and standardization of the sampling and the testing results, which Dr. Spearing mentioned. And so this really likely contributed to a varied kind of protective action response or set of responses that we observed throughout these different communities. Varied guidance led to varied protective action responses by the community members.
So thank you. So we've heard from all these speakers and representatives and their perspectives from this disaster, and it's informed by their own experiences elsewhere. I guess if we just go around the table here, one question I had is, what's your one recommendation? And if somebody else says it, it's okay to say something else. Would you have for improving the next time something like this happens, the next chemical industrial accident, to improve scientific input into disaster response or supporting their community? And the first kind of person I'll go to, I think, is Professor Loeffler. Don't hear him. Professor Loeffler, you muted.
Sorry, I got that. Unmute. Sorry about this. So when we think about contaminants, right? Typically, funding agencies, politicians think about past problems, right? Contaminants have been released in the past. And if we support this type of research, about pathways and microbes degrading them, we're dealing with past problems. But especially policy, right? They look, what do we do in the next 4 years? They're not so interested into looking into past problems. And so we have to change the thinking about contaminants, right? We don't just deal with past problems. We deal with something that can happen today, tomorrow. And then we have to have solutions. But we can only have solutions if we already have the information generated. So I do not like this idea of talking about, oh, this is research dealing with past problems. This is a nice example showing to us that this research funding past problems generates information that can help us to deal with current problems. And I can see many opportunities in the future, how this information generated with legacy contaminants can help us with future problems. We also have to think about education, right? We have to educate people to actually be knowledgeable about how to deal with this type of incident. That's very important. And, many people think about East Palestine as an isolated incident. It's not. So 1982, there was a big spill of vinyl chloride in Livingston, Louisiana. In 1996 in Schönberg, Germany. In 2012 in Paulsboro, New Jersey. And now in East Palestine. My point, every 10 years, we have a spill of vinyl chloride. It's not an isolated incident. And then to me, it makes really no sense why we don't have standard protocols, guidelines in place that help first responders to deal with the immediate impact of such incidents, right? So something got lost here. We need to respond. Agencies have to respond. And we make some suggestions, and point this out in our manuscript. So I think this would be helpful to prepare for the next incident like this. And I could go on this topic, but I do believe that research in this area doesn't just deal with past problems. It prepares us for future problems.
Thank you. Thank you. Well said. Dr. Jung, do you have a recommendation for what should be done in the future?
Thank you, Dr. Whelton. Yes, I'd like to again, strengthen what Dr. Loeffler just said. A chemical disaster is happening every 2 days. So it's not in years, it's not in months, it's in days, right? So when a chemical disaster happens, you will have contamination. The contamination is that of air, water, soil. We live in communities and societies where we have all of these environmental media around us. These communities are directly impacted. So just this summer, a train derailment occurred here in Lafayette, Indiana, where we are at Purdue University, near the Harrison Bridge on a Saturday afternoon. I saw the press release and there were 4 car trains that were derailed. And my next thought was really, do I need to get ready with my instruments? Is what is in these cars? Will there be a chemical release? What are the next steps we have to do? So, we were very lucky that it did not happen and that there was no chemical release and this was contained situation. But to the communities where these things happen, this is a very real, very serious matter. When this event happens, it is very disrupting for everyone. So preparation to respond to these events in a skilled manner is very important. By meaning of skilled manner is not to use old tools that are outdated to analyze and assess what the situation is. It's not really very wise. We need to be prepared to deploy highly sophisticated instrumentation, very skilled teams. We have expertise. We have people of years of experience waiting and ready to, respond to such situations. We need to tap into those resources. We need to come up with better ways to utilize sophisticated instruments to respond to such situations and do away with the outdated methods that don't provide us with much information. And this will really help. This will really help.
Thank you. Ms. Coelho, do you have a recommendation about what needs to be done in the future based on what you've seen, not just here, but elsewhere?
Yeah, absolutely. So contributing to what Dr. Loeffler and Dr. Jung just said, I completely agree. I think when you do this kind of science, it's not only to understand the past disaster, but to understand what did you deal with and what is your next action in case similar scenario occurs in the future. So that's why on our study, we ended up with some recommendations for future disasters. So in the case of the East Palestine incident, it is very important to the lessons such as immediate evacuation and sheltering. And there is an emergency response guidebook that mentions about how many miles you should evacuate for, depending on how many rail cars you burn, carrying vinyl chloride or other chemicals. You also need another a lesson is to provide medical care and monitoring for people who were exposed to hazardous chemicals, including decontamination when necessary, and improving the environmental assessment and cleanup process in general to remove the chemicals from the affected areas and prevent the long-term effect in the community or everyone involved, workers and bystanders that are nearby to those affected areas.
Okay, thank you. Ms. Taggart, looking ahead, what could change the way we respond to disasters in your experience? I know you might get called in right after they happened, or when maybe a client gets stuck and they had degradation happening, but it's not anymore, and now the chemicals are hanging around. What do you think nationally could be positive to facilitate faster removal of the contamination from the area, but also maybe minimizing that it happens in the first place to the extent it does?
Yeah, I think there's one sentence that was like my biggest take home from East Palestine was lessons learned from the past are able to create actionable data for the future. So if we can take what we've learned from all of the history, we're constantly learning more. We learn new things at each site, at each spill that happens, but we already know a lot. So when you take the experts like we have on this panel, using a multiple lines of evidence approach, you can actually create a really thorough plan that's protective in a reasonable amount of time. It doesn't have to be a huge research project that's taking years to generate data from, right? We can do something with a faster response. We can have some plans already in place. And then, like Clayton was saying, we have to be sure we disseminate this information at the proper level and not just to certain people, but to everyone in the situation that needs the information, whether it's the public, whether it's people handling all points, public contact, immediate response, containment, then remedial approaches come into play. And so I think we need to pull what we already know, create some type of document and planning, like an ITRC document or something that can help us move forward, and then use that as actionable data for what we're going to do from here on out.
That's excellent. That's an excellent recommendation. Clayton, since you were invoked, what would be your recommendation? If you had one recommendation to make moving forward, what would it be?
Yeah, that dissemination of information. So first, I second the need to improve protocols. Responsible parties, in this case, the responsible party was required to create a mitigation and prevention plan. I think there's a real opportunity for, at that point, for EPA personnel or for third-party partners to enhance those documents and that information. And then again, getting back to disseminating that information, in this case, like I'm sure that there's a information and communication technology kind of solution to give first responders access to that information quickly to eliminate the information asymmetries that I think Dora was alluding to.
Okay, thank you. And Professor Spearing, I wanted to let you close out the panel with your recommendation. I know you have many recommendations, but what one recommendation moving forward, hearing everything we've heard, do you think could really help lessen the impacts of something like this in the future, and also help the people of East Palestine in the surrounding areas that are still asking questions about their own health and safety?
Yeah. Well, I want to second the recommendations from the rest of the panel, especially around standardization and communication. One thing that we didn't talk about as much was the idea of kind of redefining the role of the responsible party immediately after disasters. And Clayton, you alluded to this, but I think our data really showed this. So we saw that 21% of people did receive some sort of sampling and testing from Norfolk Southern or contractors. But Norfolk Southern was the least trusted source of information, and only 1% of people said it was their most trusted source of information for testing. But almost a quarter of the people who responded were getting testing from Norfolk Southern and its contractors. And so that kind of created a challenging context around, trusting information. And so one of the things that our paper and what we recommended is kind of redefining that role. And we think that a more neutral agency could come into play here, especially around coordination of household eligibility for different resources. And so that resource, again, could include sampling and testing, right? But it also can include other resources such as reimbursements for hotels, which were done typically after spending. So the burden of paying for a hotel during evacuation was on the household, sometimes for weeks at a time, right? And because of some uncertainty there wasn't a clear appeal process. If a community member wanted to disagree with a decision made or eligibility, it wasn't clear. And so one of the things that I think looking forward is really redefining the role of the responsible party in terms of providing information and resources directly to impacted community members.
Thank you. Thank you. And so with that, we will close today's webinar. I want to say thank you to all the panelists who joined us. And I'd also like to acknowledge the many people who contributed to the work that these panelists presented. And so there's probably at least 50 people that are undergraduate students, graduate students, postdoctoral associates, other faculty, and staff at Microbial Insights and elsewhere. Further, none of this would have been possible really without the community members and businesses reaching out to us and asking us for help. A lot of us designed the questions that we work to answer because of direct feedback from households and businesses. And so we thank you for your participation and your support in enabling us to help you answer some of these questions. Financial support for these studies was provided by the United States National Science Foundation, and that is deeply appreciated. The Purdue University Institute for Sustainable Future helped put together this webinar. And finally, in conclusion, I'd just like to put something out there. You've heard many recommendations and discoveries from these 4 research teams. There's a number of different universities and other groups out there working on things like this for other disasters. What we don't yet have in the United States is a focused, concerted effort to harness the power of all of this science, engineering, policy, and practice expertise to transform the natural and man-made disaster response system in the United States. And what you've heard today could be the start of that. So I encourage those in policy decision-making capacities to listen in, to feel free to reach out to any of the panelists today to find out if there's ways that we can work together in a public and private approach to transform how we use science to better protect communities after disasters or even prevent them from occurring in the first place. So thank you for tuning in, everybody, and we wish you all a pleasant day. A copy of this slide and presentation, as well as the video, will be posted at plumbingsafety.org, and feel free to reach out if you have any questions. Thank you.